So example number 4, express 5 cos theta plus 12 sin theta in the form r into cos theta minus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Hence, solve the equation 5 cos theta plus 12 sin theta is equals to negative 6. So the first case, you've been told to express 5 cos theta plus 12 sin theta to be in the form r cos theta minus alpha. So it is this left-hand side equation we want to appear in this form. So what we do, we have here cos theta minus alpha. So what is cos theta minus alpha? Cos theta minus alpha is a cosine difference angle formula. So from the cosine difference angle formula, we found that cos theta minus alpha is simply cos theta cos alpha. Then when there is subtraction, the other side is addition, isn't it? Then sin theta sin alpha. Meaning if you have cos A minus B, that is simply cos A cos B. Then if this left hand side is subtraction, the right hand side is addition. Then sin A sin B. So in our case, we have theta and alpha, meaning where there is A, we put theta, where there is B, we put alpha. So cos theta minus alpha is cos theta cos alpha plus sin theta sin alpha. Then we now want r cos theta cos minus alpha. So it means we multiply both sides of this equation by r. So for us to get r cos theta minus alpha, we multiply both sides of this equation by r. So we are going to get r cos theta minus alpha to be equivalent to, remember r, what is outside is a common factor of everything inside, isn't it? So r multiplies all the terms inside the bracket. So there we'll have r cos theta cos alpha, isn't it? So r cos theta cos alpha, then plus r sin theta sin alpha, isn't it? Now this equation is what you compare with the equation you were given. The equation you were given 5 cos theta plus 12 sin theta. That is the equation you were given, isn't it? So it means cos theta is common in both two equations, isn't it? In the first terms, cos theta is common, and in the second term, sin theta is common, isn't it? Meaning r cos alpha is a coefficient. So it means r cos theta cos alpha, you can rewrite it as r cos alpha then times cos theta, isn't it? Then plus r sin theta sin alpha, you can rewrite it as r sin alpha then times sin theta. So that you can see the coefficient of cos theta in the upper equation is 5, and the coefficient of cos theta in this one, you are comparing it with r cos alpha. These two equations are the same, so you are comparing their coefficients, isn't it? The unknown coefficient must be the same with the known coefficient, isn't it? So the unknown coefficient here is r cos alpha, which is a coefficient of cos theta. Then here the known coefficient is 5, which is a coefficient of cos theta. Meaning this 5 must be the same as r cos alpha, isn't it? Are you seeing that? So it implies r cos alpha is equals to 5. You do the same with the second case. R sin alpha is the coefficient of sin alpha in this equation. So it means 12 sin alpha, 12 is the coefficient of sin, not sin theta I mean, isn't it? 12 is the coefficient of sin theta. So you compare the coefficients of sin theta, isn't it? So for the coefficients of sin theta, we have r sin alpha to be equals to 12, because both of them are the coefficient of the same sin theta. Are you seeing that? So from these two equations, we can now make cos alpha the subject of the formula. So to make cos alpha the subject of the formula, we divide both sides of the equation by r, isn't it? So if you divide both sides of the equation by r, you divide both sides of the equation by r like that, you will get cos alpha is 5 over r and sin alpha is 12 over r. Are we together? Then we recall the elementary identity. So from the elementary identity, we found out that tan alpha is simply sin alpha over cos alpha, because we found out that tan is sin over cos, isn't it? Remember when y was equals to sin A and x was equals to cos A, then tan A was y over x, isn't it? Meaning tan A was sin A over cos A. So in this case, when you have tan alpha is going to be sin alpha over cos, isn't it? Because tan is sin over cos. So sin alpha over cos alpha is the same as sin alpha times 1 over cos alpha, isn't it? Sin alpha over cos alpha is sin alpha times 1 over cos alpha, meaning it is sin alpha times the reciprocal of cos alpha, isn't it? So there we have sin alpha. You substitute the value of sin alpha, which is 12 over r, times the reciprocal of cos alpha. If cos alpha is 5 over r, then 1 over cos alpha will now be r over 5. You see that? So r cancels out with r, you remain with the 12 over 5. So it means tan alpha is 12 over 5. So for us to get the angle alpha, meaning we use the tan ratio, isn't it? Because the tan ratio does not have the unknown. The unknowns will cancel out, isn't it? Are you seeing that? So we found out that tan alpha is 12 over 5. Tan alpha is 12 over 5. So what is alpha? For us to get alpha, we take the tan inverse of 12 over 5. So alpha is the tan inverse of 12 over 5. So what is the tan inverse of 12 over 5? So tan inverse of 12 over 5 is 67.4 degrees, isn't it? It is approximately 67.4 degrees. So we found alpha is 67.4 degrees. Why are we taking alpha to be just 67.4 degrees? Because alpha can be very many. There can be millions of such angles when you use the concept of a unit circle, isn't it? We are taking alpha to be 67.4 degrees only because we've been told alpha is between 0 and 90 degrees. Inclusive. Equal sign means 0 and 90 degrees are included in that range. Are you seeing that? So between 0 and 90 degrees simply implies that alpha is an acute angle. Are you getting that? So they are telling you that you can get very many values of alpha, but they are only interested in a case which is an acute angle. Are you together? So it means the case we found directly from the calculator is the case of an acute angle, and that case of an acute angle is what they require. Are we together? So we found the value of alpha. So getting the value of alpha, we use the tan ratio. Then the next thing we have to find is the r, isn't it? How do we get the r? Now for you to get the r, we use the Pythagorean identity. So remember from the Pythagorean identity, we said cos squared A plus sine squared A is 1. That was the first Pythagorean identity, isn't it? Now in our case, we have alpha. We don't have A because it is alpha which is relating with r, isn't it? You can see here cos alpha is 5 over r, and we have here sine alpha is 12 over r. So it is alpha which is relating with r, isn't it? So it means we can use Pythagorean identity to get r. So it means instead of A, we have cos squared alpha plus sine squared alpha is equals to 1. That is a Pythagorean identity if alpha is the angle, isn't it? Are you seeing that? So cos squared alpha can be written as cos alpha, the whole of that squared, then plus sine squared alpha is written as sine alpha, the whole of that squared, to be equivalent to 1. Then we substitute the value of cos alpha. So what is the value of cos alpha? Where there is cos alpha, put the value of cos alpha. Cos alpha is 5 over r. Then where there is sine alpha, put the value of sine alpha. Sine alpha is 12 over r. So from there, now the square which is outside is for all the factors inside, isn't it? So it means this is 5 squared over r squared plus 12 squared over r squared is equals to 1. So we can multiply both sides of the equation by r squared to get rid of r squared in the denominator, isn't it? So it implies that r squared will cancel out on this right hand side equation, will remain 5 squared plus 12 squared is equals to r squared. So what is r? R is the square root of 5 squared plus 12 squared. So what is the implication for that? Meaning when you are looking for R is like a case of a radius. You don't need to go all that long process. That is a process of explanation. What you simply need to take for you to get R is simply the Pythagoras theorem of the coefficients, of the two coefficients 5 and 12. Meaning for you to get r squared, you simply take these coefficients 5 and 12 regardless of the sign between them. Whether it was minus 12 sin theta or plus 12 sin theta, that negative sign does not matter, as we'll see later on, okay? What matters are these coefficients of the cos and the sine of the compound angle. You simply take the Pythagoras theorem for those coefficients. You don't need all that long process I've used for explanation. Have you seen that? So you say r squared is simply 5 squared plus 12 squared. Are we together? So whether here was negative 12 squared, negative squared will be positive, isn't it? Are you seeing that? So that is why I'm saying if here was negative, you don't need to record as negative 12 squared. You just record as 12 squared because negative squared is positive, isn't it? So we now have r is the square root of 5 squared plus 12 squared. And if you work out that, you get it is 13. Pythagoras theorem, isn't it? Relating the three sides, meaning we are assuming these two coefficients are the two shorter sides of a right angle triangle. Are you seeing that? Then r, the radius, is the longer side. So you use Pythagoras theorem to get r, and you can see that relationship is coming from the Pythagorean identity. Are we together there? Now, having found the value of r and value of alpha, then we can now express 5 cos theta plus 12 sin theta in form of r into times cos theta minus alpha. So if we have 5 cos theta plus 12 sin theta, we are supposed to be expressed in the form of r cos theta minus alpha. So for you to express it in that form, it means where there is r, you put the value of r, isn't it? And the value of r we found to be 13. Then cos theta minus alpha, we put the value of alpha. And the value of alpha we found is 67.4 degrees. Why are we taking the value of r to be 13? Because the square root of 5 squared plus 12 squared is square root of 169, isn't it? Remember, square root of 169, you get negative 13 or positive 13, isn't it? But we are saying r is 13 because you are told r is greater than 0. From the question. So you can see from the question you've been told where r is greater than 0, meaning out of those two values you are getting from the square root, they are only interested in that value which is positive. Are you seeing that? So we now have our r is 13. So now you've expressed that equation in the form r cos theta minus alpha. Having expressed that equation in that form, the second part you've been told to use, hence you solve the equation 5 cos theta plus 12 sin theta to be equivalent to negative 6, isn't it? Now, you have 5 cos theta plus 12 sin theta to be equivalent to negative 6. Are we together? Kwa pamoja? So from there, where there is 5 cos theta plus 12 sin theta is the same as 13 cos into theta minus 67.4 degrees, meaning you substitute the value of 5 cos theta plus 12 sin theta, isn't it? You know the task here, the reason why we are substituting, for us to solve a trigonometric equation, we must have a single ratio. If it is cos, there should be only cos in that problem. Are you seeing? If it is sine, it should be only sine, isn't it? So that is the reason why we are expressing this equation in the form of r cos theta minus alpha, so that we only have cos, a single ratio, so that we are able to solve it, isn't it? But if you don't express it in this form, you have cos and sine. So that one is not solvable, isn't it? Are we together? Now from there, for us to solve this, we get rid of the coefficient 13. We divide both sides of the equation by 13. To get rid of the coefficient there, divide both sides by 13. So we have cos theta minus 67.4 degrees is equal to negative 6 divided by 13. So what is negative 6 divided by 13? Now from there, we now want the angle. Remember the angle inside the cosine is theta minus 67.4, isn't it? So even if you let that theta minus 67.4 to be A, it is like saying that cos A is equal to negative 6 over 13, isn't it? If you let this angle inside the cosine, this angle theta minus 67.4 to be A, it means you have cos A is equal to negative 6 over 13, isn't it? So for you to get angle A, it means you are looking for the cos inverse of, for you to remain with A, you are looking for the cos inverse of negative 6 over 13, isn't it? Are you seeing that? So it means for us to get angle theta minus 67.4 degrees, which we say to be A, for us to remain with that angle A, then we are getting the cos inverse of negative 6 over 13. So remember, when we are looking for the cos inverse of any angle, we deem that sign which is there is to tell you the quadrant where it lies. You don't use that sign. We will use it to locate the quadrant. Are you getting that? We will use it to locate the quadrant. So how do we use it? To locate the quadrant. So you come and you draw your circle, your unit circle. So we had our unit circle which has 4 quadrants. All students take calculus. So in the first quadrant, or if in the first quadrant, if you have some angle, maybe you can say maybe some angle better in the first quadrant, meaning the angle in the second quadrant is 180 minus, the angle in the third quadrant is 180 plus, the angle in the fourth quadrant is 360 minus. Are we together? Now here, for you to get, here we have on the left hand side of the equation, we have theta minus 67.4 degrees. So what is the cos inverse of 6 over 13? You don't look for the cos inverse of negative 6 over 13. The negative side tells us the quadrant where cosine is negative. Are you seeing that? So you simply look for the cos inverse of 6 over 13, but not negative 6 over 13. Are you seeing that? You look for the cosine inverse of 6 over 13. The negative will tell you the quadrant where the cosine is negative, isn't it? So what is the cos inverse of 6 over 13? Cos inverse of 6 over 13?
62.5.
62.5, isn't it? So it means angle beta is 62.5 degrees. You know, angle in in any point we can denote by anything, isn't it? Beta, theta, alpha, anything. But theta and alpha is already used in the equation, so we can use any other letter, Greek symbol to denote the angle, isn't it? Are we together? Tuko pamoja? So from there, the angle beta is 62.5 degrees. So what is 180 minus beta? 180 minus 62.5 degrees, we have 100.5 degrees, isn't it? Then 180 plus beta, 180 plus 62.5 degrees, we have 180 plus 62.5 degrees to 242.5 degrees. Then 360 minus 62.5 degrees, we have 360 minus 62.5 degrees, we have 297.5 degrees, isn't it? Now, all those angles, we are only looking for the angles where cos is negative, isn't it? So here you can see in the first quadrant, all of them are positive. So we don't need the angle in the first quadrant because cos is not negative in the first quadrant. Then you move, in the second quadrant, only sign is positive, meaning cos is negative in the second quadrant. So we need that angle where cos is negative, isn't it? So we need the angle 117.5 degrees because it is in the second quadrant where cos is negative, and we are looking for the angles where cos is negative. Are we together? Then you move to the third quadrant, only tan is positive, meaning cos is negative in that quadrant, isn't it? So we are looking for that angle where cos is negative. So we are looking for angle 242.5 degrees. Then you move to the fourth quadrant, only cos is positive, meaning we don't need that angle. Are you seeing that? So the angle which is where cos is positive, we are not interested in. We are interested in the quadrant where cos is negative. So we found our two angles, but we don't need theta minus 67.4 degrees. We want theta, meaning we get rid of negative 67.4 degrees, isn't it? So negative 67.4 degrees going on the other side of the equation, we get theta to be 117.5 degrees plus 67.4 degrees, or 242.5 degrees plus 67.4 degrees. So what is our angle theta? Start by adding the first one, 117.5 degrees plus 67.4 degrees. We have 184.9 degrees, comma, 243.5 degrees plus 67.4 degrees. We have 309.9 degrees. So you are told to only take the values of theta which lies between 0 and 360 degrees. So you can see all these angles, 184.9 degrees and 309.9 degrees, all are in the range of 0 to 360 degrees. All of them are within that range, isn't it? So it means all of them are required. You only eliminate the one which is not in the range which is required. Are you seeing that? So that is where there is no need of adding 3602 to get more angles, because they will be outside the range which is required, isn't it? So that is how we solve a problem involving a compound angle. So that is a case of a compound angle with the cosine difference angle formula. That is how we solve a compound angle with the cosine difference angle formula.